If non-parallel sides of a trapezium are equal, prove that it is cyclic. What does cyclic mean? Cyclic means it's a cyclic quadrilateral. First thing is, what is a trapezium? Well, it's a quadrilateral, that is a four-sided figure wherein we have one pair of opposite sides to be parallel. And whatever the other two sides, they can be anything. There's no condition. Right? You can see this in your quadrilateral concept map. So you'll get to understand and recall all of this. So here in this particular question, they are telling these two sides are equal. We have to prove that this is cyclic. What does a cyclic quadrilateral look like? Is there a particular property? Yes, there is. And what is it? Yes, that is the opposite sides add up to 180 degree. Okay. So basically we have to prove that if this is x, this is 180 minus x. And if this is x and this is also 180 minus x. In this case, they'll be equal, x and so on and so forth. 180 minus x. Okay, this is what we have to prove basically. So let me do it properly. Let me shut off with black color. That looks okay, right? Yeah, that looks good enough. So what we have here is, we have A, B, C, D, a trapezium wherein these two lines are parallel to each other, right? And we have these two sides to be equal to each other, right? So let's talk about this. Let's consider a trapezium ABCD with AB parallel to CD, and actually that is given, the other aspect. I'll write it as given only. We have been given that we have AD is equal to BC. Okay. Then we have draw perpendicular line AM to DC, and that is your clue, perpendicular line B and to DC. Okay, so I won't do anything. You guys can pause and think about it. I'm not doing anything, even the drawing. Anything? Understood? So we are taking point A and drawing a perpendicular line to DC. Point B, perpendicular line to DC. This is 90 and this is 90. This is M and this is N. Right? So what are we looking at? We have the following diagram. Again, I don't want to tell actually. Think about it. I was able to tell the answer, but I think you guys should think about it. To prove that ABCD is cyclic. If we written cyclic, we'll also write cyclic. Now the proof. Okay, what is that we are looking at? So the next clue is this. We'll consider triangle AMD and triangle BNC. So what is that we are looking at? Well, these two triangles are, yes, they are congruent. How are they congruent? How will we prove this? Any idea? With anything? Okay, let me explain. Let me not tell the answer directly. So we have these two triangles. We have to prove that they are congruent. That's the agenda now. So first we'll go with AM is equal to BN. Is that correct? Because why? They are perpendicular distance, perpendicular lines between two parallel lines. Between two parallel lines. So they have to be equal. That's the whole idea of perpendicular lines. Sorry, not perpendicular line also, and parallel lines. And next thing that we need to talk about is AD is equal to BC. That is the given. If this not for this condition, we won't be able to prove this, and it won't be true also. And next thing is what? Yes, we have DMA will be equal to CNB. And why is this? Both are equal to 90 degree. But how is this possible? This is because AM and BN are perpendicular to DC. Okay, agree? And now with YRHS congruency, we have triangle AMD, which is going to be congruent to triangle BNC. Agree? So what is the whole idea of this? Well, let me go back to the original initial discussion. See, if I prove that this is x, this will be 180 minus x. Why is that? So it's because these two lines are parallel. Is it not? If I have two lines which are parallel to each other, right, something like this, it's similar. These two angles are known as what? Co-interior angles. If this is A and this is B, what is the property? Yes, we have A plus B, which is equal to 180 degree. Okay, so these two angles are 180 degree. Next thing is that if I prove that this is A, and if I happen to have this as, which is obviously 180 minus A, and if I prove that angle C is equal to A, or in this case angle C is equal to x, right? 180 minus x plus x will be equal to what? 180. What does it mean? It is a cyclic quadrilateral. So basically I am trying to prove that angle D is equal to angle C. That's the whole agenda. Okay guys, I think I didn't link that. I should have linked it over here. My bad. So the point is this. What we have here is, let me explain it as a rough picture over here. What we are trying to do is this. See, this is x and this is 180 minus x by default, because these two lines are parallel. Similarly, if this is A, this is 180 minus A. But we have to prove that they add up to, the opposite angles add up to, 180. So basically this should be x, and so this will be x. And see, if you add the opposite angles, what is coming out? 180 degree. So basically we have to prove that these two angles are equal. If not, the top two angles are equal. So I found it to be convenient to prove that below two angles are equal, right? And that's why we proved that these two triangles are congruent. Okay, I hope you guys understood. Now end of it, we are proving that angle ADM will be equal to angle NCB. Okay, and then we have, as AB is perpendicular to CD, we have angle ADM plus angle DAC, which is equal to 180 degree, right? That's what we are trying to move towards, proving that this is 180 minus x, and this is x, and this is also x, and so we have these two adding up to 180 degree. That's what we are trying to prove. So these two angles add up to 180 degree because they are, yes, because they are co-interior angles. And the next step is we're going to substitute, say 1 over here, in place of ADM we're going to substitute NCB, and these two angles are opposite angles and they are adding to 180 degree. So on substituting angle ADM from 1, right, what is happening over here? This will turn out to be angle NCB plus angle DAC, which is equal to 180 degree, right? And end of it, as sum of opposite angles of ABCD is equal to 180 degree. So this particular information infers that, from this we can confirm that this is a cyclic quadrilateral. Okay, this is the whole funda. That's it. Quite simple.